In many applications, components should have not only a high strength but also a high wear resistance. This generally applies whenever two or more components are in contact with each other. These include, for example, gears, shafts, bolts, pins, and guide rails. High wear resistance ultimately means a hard surface, so that the surface is not damaged in contact with adjacent components and thus wear is kept to a minimum. For this reason, parameters are required to characterize the hardness of a material. Before such characteristic values can be obtained, the term hardness must first be defined. In everyday life, a surface or material would be described as hard if it cannot be easily scratched. On a soft material, on the other hand, you would see clear scratch marks. And in fact, this principle of indentation of a standardized object into a material. Brinnell hardness test. In Brinnell hardness testing, the material or component to be tested is first placed under the microscope of the testing machine. The component's surface is then brought into focus by adjusting the table height. The surface now has the correct distance to the indenter. A small ball made of cemented carbide is used as the indenter. The testing machine automatically rotates the mounted indenter and the test procedure begins. The cemented carbide ball is placed slowly on the surface. The indenter is then pressed into the material surface to be tested with increasing force. The force increases to the maximum value set in advance within about 10. The indentation surface left behind, which in this case forms a spherical cap, is then evaluated under the microscope. The larger the indentation left behind, the softer the surface. For evaluation, the testing machine automatically switches back to microscope mode. The evaluation of the spherical cap is done using the diameter of the indentation. However, the outline of the indentation is usually not an exact circle. Therefore, the diameter is averaged using two diameter values at right angles to each other. With the mean diameter, the testing machine now calculates the hardness value. In this case, the surface has a Brinnell hardness value HBW of 203. The basics for determining this hardness value based on the indentation diameter are explained in more detail. Brinnell hardness is the ratio of the applied force FKP and the indentation surface S left by the indenter, which in this case forms a spherical cap. The force FKP was specified in the obsolete unit kilopond when the Brinnell hardness test was introduced more than 100 years ago. 1 kilopond was defined as the force corresponding to a weight of 1 kilogram on Earth. 1 kilopond thus corresponds to 9.81 newtons. Nowadays, forces are always specified in the unit newton. Therefore, the conversion of a force from the unit newton into the unit kilopond results from the reciprocal value of the gravitational acceleration. This conversion factor is thus 0.102. Therefore, if the force is used in the unit newton, the calculation of the hardness value must be done with the factor 0.102. The indentation surface S forms a spherical cap, which is part of the spherical indenter with diameter d. The surface area of this spherical segment can be determined from the indentation diameter d according to the shown formula. The Brinnell hardness value HBW, which is given without units, can therefore be calculated with the given formula. Material from being pushed over the edge of the specimen during testing and therefore pretending a lower hardness value, the center of the indentation should be at least as far from the edge as 2.5 times the diameter of the indentation. If several hardness tests are carried out on one single specimen, care must be taken to ensure that the indentations do not fall below a minimum distance from each other. If not, the measurement result would be influenced by hardening phenomena occurring around the indentations. Particular care must be taken when testing the hardness of a material with the same force but with different test ball diameters. With a smaller diameter, the force is distributed over a much smaller area during indentation. The material is thus subjected to a much greater load, which results in deeper indentation, but may not result in a larger indentation surface due to the smaller diameter. Cemented carbide balls made of tungsten with a standardized diameter of 1, 2.5, 5 or 10 mm are available as indenters for Brinnell hardness testing. Small diameters are necessary for thin sheets, as indenters that are too large would only bulge out the material on the bottom side of the sheet. Large indenters are also not suitable for determining the hardness of thin surface layers. In such cases, there is a risk that the surface layer will only be pressed into the underlying base material. However, larger indenters are required when testing coarse-grained materials or heterogeneous microstructures, such as cast iron. Due to the large indentation, many heterogeneous microstructural components are involved in the deformation, resulting in a hardness value that covers the entire microstructure and not just individual areas. Heterogeneous microstructures is the special advantage of the Brinnell hardness test. In principle, however, it is only suitable for soft to medium hard materials. Depending on the material, the Brinnell method can cover hardness ranges between 10 and a maximum of 650.